All right, I guess we'll get started. So this is the last lecture on inheritance. Wrap things up. So it's a little bit of an odds and ends lecture. So to begin with, we're going to talk about static features and inheritance. So remember, your class can have static fields and they can have static methods. So static fields, they behave the same as non-static fields in inheritance, right? So they behave like regular fields. Right? So anything that's public or protected gets inherited, right, by the subclasses. If they're public or protected, static classes can access the fields directly by name, right? So nothing different there. Right? Again, if you have a private static field, that's not inherited, right? And subclasses cannot access that field directly by name. Right? If you have some sort of public or protected method, though, that gives access to the field, then the subclasses can access the static field via the method. Right? But they can't access the private static field directly. Right? So that's the exact same for all types of fields, whether they're static or not. Now, there is a difference, though. Right? So you have to remember what static means in the context of fields. Right? So a static field belongs to a class, right? And there's only ever one copy of that field. Right? So it belongs in the class that declared the field. Right? So if the subclasses inherit that field, what that means is everybody is sharing that same static field, right? Because it belongs only in one class. Right? It belongs to the class that declared it, and that's the only copy of the field that exists. Which is a little bit confusing. So it's strange that Java says that the static fields are inherited when really the field still lives in one class, right? It's declaring class. Okay, so we've got this little inheritance hierarchy. It's not very deep, right? It's only one level deep. X is the superclass, right? Now let's suppose that X declares a static field, right? And it's protected. So it's protected int, which means the subclasses have access to that field. Right? So Y, Z, and W can all access that field. Furthermore, Y, Z, and W, they all inherit that field. Right? And so what most programmers think when they see this for the first time is that if Y, Z, and W all get their own copy of that field X, right? They don't. Right? The only copy of the field X lives up here. Right? So all that inheriting the field does is it lets Y, Z, and W access that field by name. Okay? All right, so what happens if you do this? Right? So I use the class X, right, to access the field X, and I set it to 1. Right? And then I use the class Y to access the field X and set it to 2. Right? And I do the same thing with Z and W. Right? So each class sets the value of the field to a different value. And then you start to print them out, right? So what's the value of x dot x? It's not 1, it's 4, right? What's the value of y dot x? It's not 3, it's 4. Z dot x, it's not 3, it's 4, right? And w dot x, well, it's 4, but that's not that surprising, right? So what's going on here, right? Whenever you say something dot x, right? If x is static, it's changing that one copy of the field, right? So x, big Y, big Z, big W, they are all sharing that little X field. Right? So if one changes it, every other class sees the same change. Right? So this is all legal, what's written up here. Right? It's even the way you're supposed to access the static field. Right? It's fine because static fields are inherited. Right? But it is confusing when you see it the first time. That's the other reason why it's important to name your classes with a capital letter, right? So if you start naming things with lowercase, like classes with lowercase letters, when you write something.x, you can't tell if it's a static field that you're accessing or if it's a non-static field that you're accessing, right? When you look at this and you see big X.x, you know right away that it's a static field, right? If you see big Y.x and you know that you're in an inheritance hierarchy, right? Then you've got some idea that field X may not belong to Y. Right? Okay, now to make it even more confusing, the language lets a subclass declare a static field having the same name as a field that it inherited. right? So your subclass can declare a static field having the same name as a static field in another ancestor class, which is really confusing. It also leads to a lot of errors when you use static fields. So you should avoid doing this. Now, what happens if a subclass declares a static field with the same name as a field in the ancestor class? Right? So what happens is inside the subclass version of the static field takes precedence. Right? So in other words, the subclass version of the field hides the inherited version of the field. Okay? You should really not do this if you can avoid it. Right? Okay, so now x, y, z, w, they all declare their own static field x. Okay? So they all declare a static field. You can even change the access modifier if you want to. Y, z, and w can change protected to private or public if they want to. Right? So they all declare a static field, their own static field. Right? Now, when you do this example, right? So if I set x using big X, I set it to 1. If I set x using big Y to 2, and I set x with big Z to 3, and if I set x with big W to 4, right, they all print out the values that you might have first expected originally. Right? So now x.x is 1, y.x is 2, z.x is 3, w.x is 4, right? Because they all have their own independent copy of the static field x, right? Which is legal. It's weird though, right? It's weird. What's even weirder is when you do something like this, right? So I make a variable of I make it a variable whose declared type is big X, right? So I call it obj, and I store a W object in it, right? Which is legal, right? W is a subclass of X, so I can store an instance of W in a variable of type X, right? Now when I access the static field using the object reference, which you're not supposed to do, but you are allowed to do it, right? So when you access the static field with the object reference, right, the question is now what happens, right? Do you get W's version of the static field, or do you get X's version of the static field, right? So static fields belong to classes, right? When the compiler looks at this expression, right, it looks at the declared type of obj to determine whether or not it can access that field X. Right? So remember, it's the declared type that determines what you can do with a reference. Right? So the declared type of obj is big X. So obj.littlex means big X.x. It does not mean big W.x, even though the runtime type of obj is in fact W. Right? So the runtime type does not come into play when you're working with static features. Right? It's only the declared type that matters. Right? So when you write obj.x, it's x.x that you get, and it's 1. Right? So that's bad. This is a bad example. This is something you should not do for 2 reasons. Right? Reason number 1, you should not redeclare static fields with the same name in the subclasses. Right? Reason number 2, you should not access a static feature via an object reference. You should always access the static field via the class name. Right? Unfortunately, the language lets you do both things. Right? So you have to be aware that this can be a problem. Now, fortunately, static fields aren't that common. Right? And static fields aren't that common. So this problem normally doesn't come up. Right? But if it does, it's very hard to decipher what's going on. Okay? So the key to remembering all this is that static stuff belongs to a class. Right? All right, any questions about that? It's strange when you see it the first time. Okay? Now, what about static methods? Okay, so first we have to go back a couple of steps, and I have to remind you about dynamic dispatch. Right? So when you call a non-static method using an object reference, right? So X is my object, right? And I call some method with X, right? It's the runtime type of X that determines which version of some method gets called, right? So now the runtime type matters. The declared type only matters to determine whether or not you can call some method. Right? The actual version of some method that you get depends on the runtime type of X. Right? So remember the printer, this little print method here, right? I can pass in any object up here, right? But the version of toString that gets called depends on the runtime type of obj, right? So if I pass in a string to print, I get the string version of toString. If I pass in a list as obj, I get the list version of toString, right? So for example, right, if I print s, right, I get the string version of toString. When I print the list t, I get the array list version of toString. And when I print this date o, I get the date version of toString. Right, runtime type matters here. Right, so now it's the runtime type. So this thing on the right-hand side of each assignment expression. Right. Okay, so what about static methods? Right, so there's a big difference between calling a static method and calling a non-static method when you're working in an inheritance hierarchy. Right, so there's no dynamic dispatch on static methods. Right, so let's go back one slide, 2 slides. Right, so remember how dynamic dispatch works? It works when you call, sorry, 3 slides. When you call a method with an object reference. Right. So when you call a method with an object reference, but you don't call a static method with an object reference, right? You call a static method using the class name, right? So because you call a static method with the class name, there is no dynamic dispatch on static methods, right? Because they're always invoked using the name of the class, even if you try to invoke the class, the method with an object reference. The compiler converts that to a converts the object reference to the declared type of the object, right? So it ends up calling the method with a class anyway, right? Now because you're calling it with a class, there's no dynamic dispatch, right? So what does that mean? That means you can't override a static method, right? Because a static method overriding a method because when you override a method, it's the runtime type of the object that matters. Right, here there is no runtime type. It's only the static type, or it's only the declared type that matters now. Right, so no dynamic dispatch on static method. Therefore, you cannot override a static method in a subclass. Right, so when you call a static method, you always get the method defined in the class that you called the method with. Right. Okay, so suppose x defines the following static method. Right, all it does is it prints out some method in x. Right. But it's static, right? Y, Z, and W do not have this method, right? However, you can still call it using Y, Z, and W, right? Because it does inherit the method. Right? It's public method, so it's inherited, right? So when you call some method using X, it prints out some method in X, right? When you call some method with Y, it prints out some method in X. And when you call it with Z or W, it prints out some method in X, right? All right, now, as with the fields, you are allowed in a subclass to declare your own version of a static method, right? It's not overriding the static method, right? Because you can't override one. So what ends up happening is the subclass version of the static method hides the inherited version now. Right? So the hiding thing still comes into play, right? Only this time it's very confusing because normally when you declare a method with the same name and parameters in a subclass, you're overriding the method, right? In a static class, that's not what. In a static method, that's not what's happening. You're actually declaring a new method. Right? So there's an error on this slide if you downloaded it from the from OnQ. That says some method in X on the OnQ version. It's some method in Y. Right? So now Y, right, which is a subclass of X, declares its own method called some method, right? And it prints out some method in Y. Z does the same thing, prints out some method in Z, right? W also does the same thing, right? Prints out some method in W, right? These are all static methods, right? That version of some method, right, hides the version that was inherited from X. Right? That version in Z hides the version that was inherited from X, and that one hides the version that was inherited from X. Right? So now when you use the class name to call some method, you actually get the method that was defined in each class. Right? So when you say X some method, now you get some method in X. When you say Y some method, you get some method in Y, and so on and so on. Right? So you get the version of the method that was defined in the class that you called the method with. Right? Here you get x, y, z, and w because each class defined its own method with the same name, and same name, parameter list, and return type. Right? Here, you only get some method in x because there's only one method called some method, and it lives in the class x. Right? However, y, z, and w inherit that method, so they're allowed to call it too. Okay, so in summary, the way to remember all this is that static features belong to classes, right, not to objects. So that's the easiest way to remember what's going on in this case. Right? So for fields, there's only ever one copy of a static field, right, and it belongs to the class that declared it. Right? If a subclass redeclares a static field, that copy of the static field belongs to the subclass. For methods, there's no dynamic dispatch on methods. Right? The version of the method that you get is the version of the method that belongs to the class that you called the method with. Right? X.some method calls some method in X. Right? Y.some method calls the method in Y if Y defined it. Right? If Y inherited it, then you get the version from X. Okay? But if you remember that first bullet, which you should anyway, because that's what static means in Java, right? Then you can figure out what's going on in most cases. All right, anybody got any questions about static features and inheritance? Okay, moving on. Final classes. So we've used the keyword final once in the course so far, right? So we've had final fields, right? So remember, a final field or a final variable, you can only assign a value to that field or variable once. Right? After you've done it once, you can't assign a value to it ever again. Right? Now, there's actually 3 uses of the word final in Java. Right? So you can have a final class. Right? So a final class is a class that cannot be subclassed. Right? So in other words, it cannot act as a superclass. Right? Or you cannot create a child class or a subclass of a final class. Right? So in other words, the inheritance hierarchy stops at a final class. Now, why would you want to do that, right? So there's a good reason why you want to do that, right? It's done to prevent other programmers from trying to extend the class that must not be extended, right? So now, why would you want to prevent people from extending a class, right? So in particular, if you're trying to create a class that represents something that's immutable, you have to declare the class to be final, right? Otherwise, it's possible to subclass that class, right? And whoever's subclassing the class can now make your class not immutable, right? In other words, they can make it become a mutable object, right? So if you poke around in the standard library, right, you will see a bunch of classes are declared final, right? String is one of them. Right? String represents an immutable sequence of characters, so it's declared final. Right? Big I integer, big F float, big D double, right? All the wrapper classes, they're all final. Right? It turns out the instances of the wrapper classes are all immutable. Right? And there's a bunch of other immutable classes in Java. If you look at them, they're all declared final. Right? Now, you might wonder why this is true, right? So why is it that if I subclass an immutable class, is that subclass not immutable anymore? Right? Okay, so let's cook up a little immutable 2-dimensional point class, right? So we're going to cook up a class that's similar to point2, except a point2 object's not, you can't change the coordinates of a point2 object. Right? It's easy to do. Right? So you make your class point2, everything's the same, right? Except you don't include any methods that change the coordinates of the point. Right? You've got a constructor that can set the coordinates of the point, right? But now there's no methods that can change the coordinates of the point. Right? X and Y are private, so nobody outside of I point 2 can change those fields. Right? They can't reach into the class and change them because they're private. I've got this method called move that looks like it moves a point. Right? So in other words, it looks like it changes the coordinates of the point, but it doesn't. Right? Instead, what it does is it returns a new point whose coordinates are equal to the current point, right? That's been moved. Right? So you take the current point, it's immutable, you add x and dx and dy to the coordinates of the point, and that gives you a new point. Right? The original point is still there, still has the same coordinates. right? And you don't add any other methods that can change the coordinates of the point, right? So this is an immutable two-dimensional point. Okay, so the problem is you did not make the class final, right? So somebody can come along, take your immutable point and subclass it, right? Because that's what inheritance is for, right? But when they subclass it, they don't have to keep the point immutable, right? So someone can come along, extend I point 2, right, by making a bad I point 2, right? Oh, sorry, hang on, this is not good. I'm doing exactly what you're not supposed to do. Sorry. You shouldn't have those fields there, right? It inherits the field, it's using the fields from the superclass, right? No, sorry, hang on. This is not, this is a bad example. This is terrible, sorry. This slide was made up, that you do need those here. Let me explain why. Oh, hang on. Control Z. There we go. Okay. So this one is a little confusing. All right, so I'm going to extend I point 2, and I'm going to add my own copies of the fields x and y. Right? Now, normally you don't do that when you inherit, right? Normally, you try to reuse the fields from the superclass. You can't do it in this example because the fields in the superclass are private, so they're not inherited. Right? But there's nothing in the language from stopping you from redeclaring those fields in the subclass. Right? If you're not happy with that, you can give them different names. Right? But it's fine. Right? So I'm going to call those x and y. Right? My constructor does exactly what it's supposed to do. It calls the superclass constructor. Right? I inherit move. I'm allowed to override move. Right? There's nothing stopping me from doing that because it's a public method, so I can override it. Right? When I override it, right, I can make the point mutable. Right? I can add dx to this dot x. I can add dy to this dot y. In other words, this point that's supposed to be immutable now moves. Right? Its state changes, right? Which is not good. Right? You can make this worse. You can add in methods that actually change x and y. Right? So you can add a method called set x that changes x. You can add a method called set y that changes y. Right? You can add a method called set that changes x and y. Right? And so on and so on and so on. Right? Because there's nothing from stopping you from adding extra methods to a subclass. Right? So your immutable point is no longer immutable. Right? So there's a slide way back when we talked about composition, right, that mentioned this recipe for immutability. Right? So if you want to make an immutable class, it turns out there's 5 things you need to do to make sure that your class really remains immutable. Right? One of them, part 2, right, rule number 2, is prevent the class from being extended. Right? So the way you do that is you mark your class as being final. Right? You have to do a bunch of other stuff too. Right? So all this other stuff here is also required, right, to prevent anybody from making your class, to make sure that the class really represents immutable objects. Right? So that explains why rule number 2 is there. Right? So when I talked about this during composition, I told you that we would come back to rule 2. Well, this is why rule 2 is needed. So sorry, I don't think I ever told you how to make this class final. Yeah, I never told you how to make it final. So to make the class final, all right, public, all you do is you put the keyword final in. Right? So if you make the class final, no one can extend it. Right? So when you write this, right? So now when you try to write this, the compiler tells you you can't make bad I point 2 because you cannot extend the final class I point 2. Right? So that stops people from doing stuff like this. Okay. The third use of final is to mark a method as being final. Right? So a final method is a method that cannot be overridden by a subclass. Right? So a final class, you can't override the class at all. Right? Now, if you want to have a class that you can extend, right, so it's supposed to be used in part of an inheritance hierarchy, right, you can pick and choose which methods can be overridden. Right? So if you mark a method as being final, a subclass can't override that method. Right? This one's a little bit stranger to understand why you might want to do this. Right? So the whole point of inheritance is that you can override methods. Right? So why do I want to stop somebody from overriding a method? So if you poke around if you Google for the Java tutorial on inheritance, you'll come across this quote here. Right? It says you might want to make a method final if it has an implementation that should not be changed and is critical to the consistent state of the object. Right? So they give an example of a class called chess algorithm. Right? In chess algorithm, there's a method that calls that says, what's it called? It's called moves first. Right? And that returns the color of the piece that's supposed to move first. Right? In chess, it's always white. Right? So there, it makes sense to make that method final, because if you don't make it final, someone can override your class, and then they can let black go first. Right? So that's the example they give. There's actually a more important reason why you should mark a method final. So it's very common in a constructor. So constructors are basically supposed to initialize the state of an object. Right? Sometimes the initialization is a little bit complicated. Right? So it makes sense to put the initialization in a separate method, because the constructor and other methods in the class might want to reinitialize the object. Right? So it makes sense to have a separate initialization method. Right? If you do that, you cannot make that initialization method public or protected. Can't make it public, protected, and non-final. Right? So a constructor should never call a public or protected method to initialize the state of the object. Right? It should only ever call private initialization methods or final methods. Right? So you can make a method public or protected and final, and it's fine if the constructor calls that method. Right? You can make a method private, and it's always fine for the constructor to call that method. Right? Now, I'll explain why in a second. Now, incidentally, why do you never mark a private method as being final? Because private methods aren't inherited anyway. Right? So there's no way you can override a private method. So you never mark a private method as being final. I'm not sure what the compiler does if you try to do that. But private methods aren't inherited anyway, so it doesn't make sense to mark them final. OK, so here's the problem when you have a constructor that calls a non-final initialization method. Right? So you have to go back to how constructors and subclasses work. Right? So remember when you subclass an object, it actually has an instance of its parent class inside of it. Right? When you call the constructor, the first thing you're supposed to do is you're supposed to initialize the parent class object. Right? That parent class object initializes its parent class object. Right? And that parent class object initializes its parent class object. Right? All the way back to java.lang.object. Right? And then the subclass constructor can finish running, then its subclass constructor can finish running, then its subclass constructor can finish running. Right? So in other words, subclasses get built from the inside out. Right? That's a problem when you call an overridable method. Right? Now notice that Java doesn't stop you from doing this. Right? So there's nothing, the compiler can't do anything to stop you from calling an overridable method in a constructor. Right? OK, so the superclass object is always constructed first. Right? Then the subclass constructor completes construction of the subclass object. Right? Now what happens when you call an overridable method from a constructor? Right? The superclass constructor ends up calling the overridden version of the method. Right? So it calls the subclass version of the method. Right? The problem is the subclass part of the object isn't constructed until the superclass version, until the superclass subobject is constructed. Right? But the superclass constructor is calling the subclass method, the subclass version of the method, because it's been overridden. Right? That method's going to run on an uninitialized subclass object, which is almost certainly going to cause a problem. Right? So here's a superclass. Here's a superclass called superduper. Right? There's your constructor. Right? Everything looks fine except for this. Right? So it calls a method called override me. right? Override me is public, which means it can be overridden, right? It's the public, it's not final, so it can be overridden by a subclass, right? Override me just prints out super duper, override me, right? So very simple class. Subclass it. So I have a subclass called subEW, right? And it extends the superclass super duper, right? Now notice what's inside, right, of the subclass, right? So it's got a field that's a date that's marked final, right? Now remember what a final field is, right? Final field can only be set once, right? So that means whenever you use that name date, this dot date somewhere in the subclass, right, it should always have the same value because you can only ever set it once, right? Where do you set the date? Well, you set it in the constructor, right? So you initialize the date where you're supposed to initialize the date, right? You do it in the constructor. That's the purpose of the constructor, right? Now we're in an inheritance hierarchy, so the first thing you have to do is call the superclass constructor, right? Okay, what else do we have in this class? Well, we have override me, right? Now remember, that's the public method that was inherited from the superclass. It's called override me, so we override it, right? Because that's apparently what it's there for, right? And so this one prints out subEW override me, and then it prints out the date as well, okay? So, and it's got a main method here, right? So it makes a subclass object, and then it directly calls the override me method in the subclass. Right, now the question is what on earth does this print out? Right? So, well, what should it print out? Right? So whoever wrote this program, right, there's two reasonable things that they might expect to appear. Right? So they make the subclass object calls the superclass constructor calls override me. Right? So you might expect super duper override me to get printed out, right? Because that's kind of what this looks like is going to happen, right? So that's what that first line will do, right? Then the second line you expect this one to run, right? So you should expect the second line to print out subEW override me followed by the date, right? Okay, so that's option number one. Now option number two, right, is that whoever wrote this method really is expecting the overridden version of the method to get called, right? So that's what they're really expecting, right? So they're not expecting this to get printed out when the constructor runs, right? They're expecting that to get printed out when the constructor runs, right? So they really are expecting subEW override me followed by the date, right? And then that really should print out subEW override me followed by the date, right? So those are your two choices, right? The original intent was probably the first one, right? So whoever wrote that override me method, right, they probably really were expecting the superclass version of override me to run, right? Because it's the constructor that's calling the method, right? So you think, oh, well, it's just calling the version of the method that's defined in the class, right? And then they expect the subclass version of the method to run, right? A slightly more knowledgeable programmer might expect the subclass, the overridden version of the method to run, right? But they're probably still expecting the date to get printed out, right? What the program actually prints out is the following, right? The subclass version of the method runs, and the date is null, right? And then the subclass version of the method runs, and suddenly the date is not null, right? Which is really weird because date's final, so it should only ever appear in one state, right? Because you can only ever set its value once, right? So that's super complicated, right? So what's going on here, right? Well, you have to trace through all the steps that are happening, right? So this slide is here for your reference, but what's going on is as follows, right? So we call the subclass constructor, right, to make the object. Whoop, we come up here, right? Subclass constructor calls the superclass constructor. Good? Right? Superclass constructor. Superclass constructor calls a method, right? However, the method is not final. It's it's a method that can be overridden by the subclass, right? So that method call does not come to here, right? Because the constructor was called with a subclass from a subclass object. So in this constructor, this does not refer to the superclass part, it refers to the subclass part. So we come back to here, right? Now this line runs. So it prints out subEW override me followed by the date. But look, the date's not initialized yet, right? We're still in the superclass constructor, right? The date hasn't been initialized. So if a field's not initialized in Java, its value is null, right? Even if it's final, right? So that's why you get subEW override me null, right? Because we hit this line and we're using a field that's not been initialized yet, and that's the problem, right? That's why you don't call an overridden method, an overridable method from a constructor, right? Only after this line returns does this constructor finish running, right? Now the subclass constructor can finish running, right? So now the subclass sets the date to the current date, right? And now that line of code finishes running, right? Once that line of code finishes running, the second line of code can run, right? So now when that line of code runs, it prints out subEW override me followed by the now initialized date, right? Which is not good, right? A bunch of things have happened here, right? You ended up printing out a final field that appears in two different states, right? In this case, it doesn't crash, right? But it would not be unusual in this method here, right, for whoever is implementing that method to actually try to use the date object to do something, right? So you might say this dot date dot set time or get time or something like that, right? If you do that, you end up with a null pointer exception and your program crashes, right? So that's why you should never call an overridable method from a constructor, right? The problem is if the method's overridable and a subclass overrides it, it's the overridden version of the method that runs. The overridden version of the method that runs is running in a subclass object that's not initialized yet, right? So you should only ever call an initialization method from a constructor if it's final or private, right? If it's not final or private, then the superclass constructor calls an overridden version of the method that runs in an object that's not constructed yet, right? And you should really never do that. All right, that wraps up inheritance. Does anybody have any questions about the content in today's lecture? Anybody? Okay. Does anybody have any questions about inheritance in general? Because we're moving on in the next lecture to something else. Anybody? All right, great. The assignment 5 is out. It's not very long, but you don't have that long to do it either. You've got a little bit more than a week to do it. So get cracking on it as soon as you can. It's not that hard. Might seem hard at first, but it's actually not that hard. Okay. And that's it for today.